All right, so today what we're going to do is we're going to be talking about perimeter. Now, seems like it's a huge shift between what we've been dealing with the angles and then working with perimeter. Perimeter is probably the most common geometric idea that you've been working with the longest, because if you'll remember that perimeter simply means the distance around a polygon. And all you really need to do to find that distance is simply add the sides. So you'll remember that again from probably year 7 or even before. Perimeter just means the distance around, and all you do to find the perimeter is simply add the sides. Remember that a polygon is simply any closed shape with straight sides. So no curves, no circles, just straight sides. It can have any number of sides. And it doesn't matter how many sides, you're just going to add those sides together. But as you saw with the angles, the difference here with the perimeter is that you're going to be concentrating more on working with creating algebraic equations out of these formulas and then solving those equations. So they're going to give you a lot of unknown quantities, in other words. So we're going to look at how we can use perimeter and algebra to create some equations. So it's really good practice for our equation solving skills that we were working with before we left for lockdown. Excuse me. So we're going to be looking at some of those problems and looking at how we can make our lives easier by thinking of perimeter, even though you just add the sides to find the perimeter. There are a couple of shapes that are regular shapes that are a little easier if we actually use a formula for them. So a fixed idea of how to find the perimeter of these shapes. So let's just pop over to the book and we'll talk about some of these and look at them. Clearly, it's easier when we're dealing with pictures. So perimeter, again, is just the total length around its boundary. So that's just the length of all the sides added together. But there are a couple of some shapes that occur so frequently that they have perimeter formula. Now, that is not to say that you can't find the perimeter without just adding up the sides. You always can. But with some of these shapes, they occur so frequently that using a formula for finding them makes your life a little easier. You're also going to see later that as we move on, these formulas can be expanded upon, and we can look at other ideas using these same formulas. So let's start with the one for the square. What you know about a square is, this thing that's special about a square is that all sides are equal. So we can use the formula perimeter equals 4s. In other words, perimeter equals 4 times s, right? Remember that if they're side by side like that, that always indicates multiplication. So just multiply the length of one of the sides by 4, and that'll give you the perimeter of the whole shape. Okay. For a rectangle, what we know is that we have 2 widths and 2 lengths. And the widths are always the same, and the lengths are always the same. So we can use the formula P equals 2L plus W in brackets. There's another form of this, and that's what I was just about to say. Perimeter equals 2L plus 2W. So what they've done in this second one is simply multiply out the bracket, and it doesn't matter which one you use, they will give you exactly the same result. Sometimes this form is easier than using the bracket. Sometimes the bracket is easier. It makes no difference whatsoever, but which one you use. And then finally, we have the perimeter of a triangle. And notice what they did was they just labeled all the sides with a different letter, and you're just adding those together. So that one's very straightforward. The important thing about here is not so much the formula, it's just the way you label the sides using different letters, A, B, and C. And you'll expand on that quite a lot when we go back to triangles. Okay? Now again, you don't have to use these formulas in order to find the perimeter of these shapes, but they'll make your life easier as the definitions of the shapes become more complex. Like you saw before, we had some sides that were x minus 90 or something like that. And if you have that case, then putting it into a formula that's very static, very organized, just keeps your work organized. Okay? Now, let's look at how some of these are used. So some shapes don't have formulas, and they can't have formulas because they're not regular polygons. So like this shape, there is no formula for this shape, so all we need to do is take all of the sides and add them together. But be warned, last time we learned how to convert those, your class didn't miss anyway, did we? I forgot, never mind. So last time we learned how to convert those, so be careful when you're looking at these. These are all in meters, but that doesn't necessarily mean that they're always going to be the same units. So watch your units, okay? But if the units are all the same, all you have to do is simply add them together. With B is a rectangle, being a rectangle, and those little squares in the sides tell you that's a regular shape, that those are 90-degree angles, so it is indeed a rectangle. If that's the case, then we could use the formula. Perimeter equals 2 times the length plus the width, or you can use P equals 2L plus 2W. In this case, because I know the length and the width, and it doesn't matter which one you call which, by the way, we usually call the longer one the length and the shorter one the width, but it makes no difference. All we have to do is simply put those values into the bracket, and then we can do the math. Okay? So in this case, that one might be slightly easier than this, but it makes no difference. P equals 2 times our length was 8, plus 2 times our width, which was 6, which gives us 16 plus 12, so we would end up with the same thing. And don't forget to put your units on. Remember, with perimeter, because we're adding them together and not multiplying them, we just end up with the same units that we started with. Okay? So I know you've done perimeter quite a lot, especially when it's the irregular shapes like this one, so you just add up all the numbers. Here, they just use the little formula for that. So what you're going to do is, we're just going to use some of these, trying to focus on these formulas if it is one of these regular shapes, like this rectangle. But if it's not, you're simply going to have to add them together. Okay? So these are pretty straightforward. You just have numbers. Remember the symbols. Everywhere there's a single line, that means they're all 4 centimeters. If there's a double line, that means a double mark, that means those are all 9 centimeters, etc. And all of these are pretty straightforward. They have matching units as well. Okay? Now, go when you get here and you have some different formulas and you're finding the perimeter of them. We need to find the length of this side in order to be able to do that. So the length of a triangle. So they're giving you a little hint that you're going to need to apply Pythagoras Theorem. And you may or may not remember that. Pythagoras Theorem says that a squared plus b squared equals c squared. I don't think we've done that in this class, but if you've done it in the past, because this is a combination of shapes, we can turn it into a rectangle and a triangle. Well, the rectangle is quite easy. It's just 2 times 4 plus 2, which gives you 2 times 6, which of course is 12. So for this, well, actually, you don't even need that for these parts. I'm sorry. Losing it. Okay, we don't even need to worry about that. But just worry this side, and this side. But we need to think of it as this side being 4 centimeters so that we can then use the Pythagorean formula. Don't worry too much about this one. We might just omit this one for the time being because we're focusing on, it's not really our focus right now when we're finding those missing sides. We'll see what happens in a moment though, to see if I have to get you there, but it's not really part of this particular program. Here, the angled sides are given to us. We need to find this missing side, so it may be interesting. I'll just look at those and we'll take those out. Okay. Find the perimeter P of each of the figures. Give your answer in its simplest form. So here's what I was talking about, where you're getting into some where they're using some algebra to solve these, okay? Now, in these, they don't tell you what the perimeter is, so you're not going to be able to solve it. So look at C, for example. We have our formula for perimeter, because this is a rectangle. It's 2 times the length plus the width. And if we call this one the length and this one the width, that means we're just going to plug those in. Now this one would be easier because we have different algebraic terms here. It would probably be easier to use that perimeter equals 2 times L plus 2 times W for this one. So be flexible. The reason for that is if you plug that into there and that into there, it would be fine. You just have to combine your like terms, but some of you might find it a little easier. So we'll do them side by side. We'll do them in parallel. Let me just put it up here to the side so that you can see, and then you can make your own choice. Sorry, so we have P equals 2L plus 2W, or P equals 2 times L plus W. So we have a length of x plus 7 and a width of 2x. Just give it some paper so we can work that out. So if we use this one, everywhere there's an L, I'm going to put the x plus 7. And remember from our study of algebra that you're never allowed to replace a letter with a number or any other value without putting it in a bracket. Plus 2 times our width, which was 2x. Then you can simply eliminate the brackets. Multiplying through, that's the distributive property there. So 2 times x is 2x. 2 times positive 7, positive 14. Positive 2 times 2x is positive 4x's. Combining our like terms, we get 6x's plus 14. And since those are not like terms, we can't combine them any further. Now, if you want the other one, perimeter equals 2 times our length is x plus 7 plus our width, which is 2x. Perimeter equals 2 times, again, we'll combine our like terms, 3x plus 7, okay? Which then we would multiply. 2 times 3x is 6x. 2 times positive 7 is positive 14. So you'll see that they'll both give you the same exact result. It makes no difference which one you use. But in some cases, this one is easier. Some cases, this one looks easier. It depends on how you like to do it. But you see they give you values with some unknowns. Again, we're not able to solve that because I don't know what P is. Now, if I knew what P was, then I would have an equation which I could then solve for x, right? Now I just made that up, so don't worry about that. But you will see in a moment. I think they're going to do that to you. Okay? So again, doesn't matter that this is in a regular shape. You know that those values are the same, so there's no formula for it. Just build them up. We know all the sides. Now, we don't know this long side, but I know that this long side is the same as the sum of this bit. Oops, sorry. It would help if I turned on it. Okay. Is the same as this bit plus this bit plus this bit have to equal that whole long side, right? So we could just add up the side, these pieces, and that would give us this piece. Okay? So think about what they're giving you, what you know, and use the pieces that you have. Okay, here we go. Find the perimeter. Find the perimeter. If the perimeter is 43 meters, find your x. So once you find the perimeter of this object, then they want you to, so you'll get something like we got a while ago, where perimeter was 2x plus 14, for example, who cares? And then they tell you a perimeter, then that means you can put a number in place of that, which means we no longer have an expression, because this is an algebraic expression there, but we have an equation which we can solve for x, right? Remember, to solve it, we just need to get that x by itself. So first I'll move this positive 14, and since it's positive, I'll move it by subtracting it from both sides, which gives us 10 equals 2x. Then I still need to get the x by itself by dividing both sides by 2, which gives us x equals 5. So there, because we were given an actual number for perimeter instead of just using p, we could actually solve the equation and find the length of the missing side, or find the value of x. Okay? Now, if if you had x minus 1 and x, well, we know what x is. That means x minus 1 would be 5 minus 1, or 4. So make sure that you're careful that you're answering the questions. Now, of course, I just made all that up off the fly, so that's not relating to any of the pictures that you just saw. But it is involving the skills that you'll need to make those work. Okay? So, perimeter, again, just means distance around. Some of them have formulas, some of them don't. You don't have to use a formula if you don't want to. You can simply add up all the sides. Now, I want to go through here. We're going to omit number 4 because it uses Pythagoras Theorem, which we're going to cover and we're going to talk about a lot more later, so we're not really interested in that. Perimeter, total length of wire. Remember that perimeter means the distance around, and so if you're going to put a fence, the perimeter and the number and the amount of wire will be the same. Okay? All right, and then figure out the cost. Remember, just multiply times the cost and it'll give you that piece. Okay? So, just a quick reminder of perimeter. As much as anything, I want you to practice the algebra here because you're going to see these algebraic expressions and this simplification a lot in this section. So I really want you to focus on setting it up and solving it if you can solve it, or just simplifying it by combining like terms, etc. if you can't solve it. Another thing that I really want you to focus on here is make sure you're watching your units. Okay? So, for your work today, what I want you to do is I want you just to complete exercise 11B. It's on page 216 in your book on Snowflake. So you can work on that and get those done for me.